Hello everyone. In this period I am going to teach you science of trigonometric functions. Science of trigonometric functions. Okay. Let's consider here a unit circle, center at O, and P be the point in first quadrant. P be the point in first quadrant. P be the point in first quadrant, having coordinate A comma B, and making an angle X at the center of the circle. Obviously, you know that the distance between P to this line is B because the coordinate y coordinate is B and distance between O to this point is A. Therefore, we can say here sin x equals to B as we know previous, and cos x equals to A. Here the signs of A and B both are positive because B is lying first quadrant. Therefore, in first quadrant, sin x is a positive and cos x is also positive. Sin x is also positive and cos x is also positive. Obviously, you know that tan x equals to sin x by cos x. If both are positive, sin x positive and cos x positive, then tan will be positive. Therefore, in first quadrant, sin, cos and tan are positive. Rest are the reciprocals of these ratios, these functions. Therefore, all the trigonometric functions in the first quadrant, are positive. Let's consider now, if the point P, say Q, if the point Q is lie in fourth quadrant, what happen here? If the coordinate of A is positive and B is negative, then obviously in fourth quadrant sin x equals to minus B and cos x equals to A. Here sign change here of sin x and cos x remain positive. Therefore, we can see here that sin minus x equals to minus sin x and cos minus x equals to cos x because cos x is positive. Sin minus x equals to minus sin x and cos minus x equals to cos x. Obviously, tan x equals to sin x by cos x. Sin x by cos x. Sin is negative and cos is positive. Then the function of tan will be here negative because sin is negative and cos is positive. Therefore, in fourth quadrant, only cos is positive and sin tans are negative. Only cos is positive and sin tans are negative. Here in first quadrant, all positive. Fourth quadrant, cos positive. Similarly, we can see here in second quadrant, if the point here and having a coordinate here minus a and plus b. The coordinate of this point is minus a and plus b because in second quadrant here is a y-axis is a minus x-axis. Therefore, a is minus and b remain the positive. Therefore, we can say here sin x equals to positive. Sin x equals to b, that is positive, and cos x equals to a, that is negative. And obviously sin by cos is negative. Therefore, in second quadrant only sin is positive. Fourth quadrant, only cos is positive. In second quadrant, only sine is positive. And third quadrant, suppose here both are negative. Minus a comma minus b are the points here. Minus a comma minus b are the points here. Therefore, sine negative, cos negative. Sin x equals to minus b, that is negative, and cos x equals to minus a, that is also negative. But tan x is cancelled out here and tan x remained positive. Therefore, in third quadrant, tan x equals to positive. Look at here. First quadrant all positive, second quadrant sine positive, third quadrant tan positive, and fourth quadrant cos positive. Obviously, you know that the cosec is the reciprocal of sin x. Therefore, in second quadrant, sin x positive as well as cos x positive. In third quadrant, tan x positive, reciprocal of tan x, cot x positive. And for fourth quadrant, cos x positive. That means the reciprocal of cos x, sec x is also positive. Is also positive. These are the signs of trigonometric functions. These are the signs of trigonometric functions. It's depend on where the angle is lie. In first quadrant, second quadrant, third quadrant, or fourth quadrant. Where the angle is, where the point in a Cartesian plane, where the angle is Cartesian point or lie, then we can determine the signs of trigonometric functions. Signs of trigonometric functions. Come on now. We will be able to solve some examples on this concept. Here is a first example. Cos x equals to minus 1 by 2. X lies in third quadrant. X lies in third quadrant. Find the values of other 5 trigonometric functions. Other 5 trigonometric functions. That means here we have given that cos x equals to minus 1 by 3 and x lies in third quadrant. As you know, third quadrant cos is negative. Therefore, cos x is equal to minus 1 by 2. We must know the identities to solve these types of questions. And the first identity is sin square x plus cos square x equals to 1. From this identity, we can derive the sin square x. Sin square x. Sin square x. Sin square x. From this identity, we can derive the sin square x, the value of sin square x. Let's solve it. Sin square x plus cos square x. Cos square x means minus 1 by 2 square. Here we have the value of cos square x minus 1 by 2 and equals to 1. Sin square x equals to 1 minus 1 by 4. Sin square x equals to 4 ones are 4 minus 1 3 by 4. And taking the square root both sides, we get here sin x equals to plus or minus root 3 by 2. Plus or minus root 3 by 2. We know that the x lies in the third quadrant. Therefore, in third quadrant, sin is negative. Therefore, we take the value negative root 3 by 2 here and avoid the positive value. Therefore, the value of sin x equals to minus root 3 by 2. Minus root 3 by 2. We know that tan x equals to sin x by cos x. Tan x equals to sin x by cos x is equals to minus root 3 by 2 divided by minus 1 by 2. 2 to 2 cancel here, and minus to minus also cancel here. We get the value of root 3. And obviously we know that in third quadrant tan is positive, and here we get the value also positive. Therefore tan x equals to root 3. Rest are the reciprocals of these functions. We know sin x equals to minus root 3 by 2. Therefore cosec x equals to minus 2 by root 3. We know that cos x equals to minus 1 by 2, which is given to us. Therefore sec x equals to minus 2. We calculate the value tan x here. Tan x equals to root 3. Therefore cot x equals to 1 by root 3. These are the all trigonometric ratios, trigonometric functions lies in third quadrant. Thus this is our first question. Okay, now second question. Second question is sin x equals to 3 by 5. X lies in second quadrant. Here also we can use the identity, the previous identity. Sin square x plus cos square x equals to 1, because we have the value of sin and we can calculate the value of cos x from that identity. So from the identity, sin square x plus cos square x equals to 1. We can derive here value of cos x. Sin square x means 3 by 5 whole square plus cos square x equals to 1. 3 square 9 by 5, 5 square 25, 9 by 25 plus cos square x equals to 1. Cos square x equals to 1 minus 9 by 25. 1 minus 9 by 25. So cos square x equals to 25 minus 9, that is 16 by 25, and cos x equals to plus or minus root of 65, 16 and 25, that is 4 by 5. Look at here. Cos x lies in second quadrant. Sin x is positive and cos x is negative. Therefore, we take the value negative here and positive void. Therefore, cos x equals to minus 4 by 5. Now, so tan x equals to sin x by cos x. Tan x equals to sin x by cos x. We have the value of sin x 3 by 5, which is given, and the value of cos x we derive here minus 4 by 5. Here 5 to 5 cancel here, and we get the value of tan x is minus 3 by 4. Okay. In second quadrant tan is negative, value is we get here negative is right. Cot x is a reciprocal of tan x, that is 1 by tan x. Cot x means 1 by tan x, that is minus 4 by 3. Sec x sec x is a reciprocal of cos x, that is 1 by cos x. We have the value of cos x minus 4 by 5. Therefore, sec x is minus 5 by 4, and cosec x equals to 1 by sin x. We have the value of sin x 3 by 5. So cosec x is 5 by 3. Only cosec and sine are positive here. Only cosec and sine are positive here. Rest are the negatives. Okay.